Hello everyone, in this video we will see the bowing effect and the strategies that we can use to avoid this undesired effect when patterning with a t-SPL. This is a part of the advanced t-SPL patterning control videos, so hopefully you will be able to understand better how we can pattern with a t-SPL with good results. So first of all, what is the bowing effect? We have to keep in mind that in order to bend our cantilever, we apply a voltage between the cantilever capacitive platform and the substrate. But the cantilever and the substrate form a capacitor, and this capacity depends on the dielectric material that is between the substrate and the cantilever. So when the cantilever is over a pattern area, the capacity is lower, so the force is reduced. In order to avoid this reduction of the force, we have the bowing correction scheme that compensate this effect by increasing the force voltage where needed. From the NanoFrazor software, we have two ways of compensating the bowing effect. One is the bowing correction and the other one is the bowing prediction. What is the difference between the two? Well, the bowing correction is applied based on the result of the reading of the written lines, while the bowing prediction is applied based on the electronic deflection during an out of contact read, in a similar way that is done the thermal conductance correction. First of all, we need to also keep in mind that the bowing correction can only be applied when using Kalman Feedback Mode. So we can see here that we have the bowing correction that's crossed. We can decide to apply it or not. But if we choose, for example, PID mode of feedback, we cannot turn on the bowing correction, and similarly if we have feedback disabled. On the other hand, we can see that for the bowing prediction, we can turn this parameter on whether we have disabled feedback mode, PID feedback mode, and Kalman feedback mode. So this is one thing to keep in mind. So now we can see together how to recognize, hopefully from a pattern, when we have some bowing effects, and how to correct them, and how the bowing correction, for example, works. So let's start this pattern. We can use a Kalman feedback without any bowing. So let's press play here, and let's see the results of the pattern. It's good to keep in mind that for each of these corrections, both the bowing correction and the bowing prediction, we can choose some other advanced parameters such as the gain or the polynomial order for the bowing correction, or the read force voltage, for example, and again the polynomial order and the pooling height approximation that can improve our bowing prediction. So let's see now what we see when we pattern. Hopefully we see some bowing which we can correct. So now we're patterning a example of a contact or a piece of a contact structure for nanostructures. And usually we see the bowing effect as more evident on the beginning, at the beginning of a step or at the end. Here it's not super clear. Here I will say it's a little bit more evident, this sort of bowing. So let's see what happens when we use the bowing correction. So we just cross this. Hopefully we can get rid of this imperfection at the beginning of the line. So usually it takes a little bit before the bowing can start being effective. We can also see in the analysis panel that as soon as we turn on the bowing correction, we have indeed a voltage that is applied, which changes depending on the geometry. So we see that we apply around minus 0.1 volt from the left, and then it kind of goes back to A0. But before we cross the bowing correction, we were not, of course, applying any bowing. And similarly, the bowing prediction, now it's turned off, but we can see what happens if we turn it on. Actually, you can only turn it on for the other two feedback modes, so now we cannot turn it on, but we can see, for example, that now on the left we don't have this bowing effect anymore. So the correction is helping us to achieve a better patterning. The bowing correction is not always turned on. In some cases, it may cause some issues with the feedback. So most cases, I will say the bowing correction can help you in achieving better patterning with the feedback mode Kalman. Also, the bowing prediction can help you improve your patterning quality if you're struggling. But these two options are usually turned off because in rare cases they can also cause some issues with the feedback. So I would say it's important to recognize when we can use the bowing correction to improve our patterning, and also how these two bowing correction and prediction act on the cantilever. So they modify the voltage that we apply to bend them in order to correct this change in capacitance. The bowing correction.